Okay, point A has a coordinate minus 2, 5, and B has a coordinate 8, minus 6. Find the equation of straight line AB, given your answer in the form px plus qy equals r. Okay, I'm going to start by drawing a sketch. Okay, so minus 2, 5 is up here. That's going to be A, minus 2, 5. And B is going to be this one here, which is 8, minus 6. And what I'm actually going to do is y equals mx plus c, because I like to stick to my GCSE ways, and I'll need to do that line there. Okay, so I'm going to do my gradient. So I'm actually going to pretend this like a right angle triangle. Okay, and just remember this goes down this way, so my gradient needs to be negative. So I've got my height, which is going to be 11. I've got my base, which is 10. So now my gradient is at negative 11 over 10. Just going the other way. So I've got y equals negative 11 over 10 x plus c. And let's substitute some values in to get c. So I'm going to do my first one. So 5 equals minus 11 over 10 times minus 2 plus c. So I've got 5 equals, that's positive 22 over 10 plus c. I'm going to bring my 22 over 10 over. So I've got 5 minus 22 over 10. Okay, so c should be 14 over 5. Okay, I'm just going to substitute these values in to see if it is right. So I've got minus 11 over 10 times by 8 and then plus 14 fifths. Hopefully that should give me minus 6, so it does. So my equation's y equals minus 11 over 10 x plus 14 fifths. And that'll be fine, but it does ask it in the form px plus qy equals r. So let's bring this over. Y plus 11 over 10 x equals 14 fifths. And these are fractions, they normally have to be whole numbers, so I'm going to times it all by 10. So I've got 10y plus 11x equals 28. And there's my answer. Okay, now the second bit, and this is really what I want you to pay attention to. The point C has a coordinate k and k plus 1. Given that ACB is a right angle, find the two possible values of A. So I'm actually going to use my previous sketch, and I've already drawn a right angle triangle. So I'm going to put this as C, and that's k comma k plus 1. Okay, and then what I'm going to do is I'm actually going to look at this, and I'm going to look at my height, which is actually going to be my difference in y's. So it's going to be k plus 1 and minus 5. And then we'll look at the opposite here, which is going to be k minus 8. Now, that's actually wrong. Okay, and if I do that and I try and create an equation from it and I solve it, I'll get something that can't be solved. And that's because this one here is sort of like not true. I've assumed that these lines are horizontal and these ones are vertical. Yeah, because my right angle could really be there and there. Okay. Now what I'm going to do is I'm just going to redraw this so I can just work through this differently. Okay, so I've redrawn this now just so it doesn't look as complicated as it was before. I'm going to work each little bit out individually. Right, AC. Now I'm going to look at this one. So I've got k minus negative 2 squared plus k plus 1 and minus 5 squared. Okay, now that's just all of this square rooted, of course. So it's going to be k plus 2 squared plus k minus 4 squared. Now I'm just going to expand everything. So I've got k squared plus 4k plus 4, and this one here becomes k squared minus 8k plus 16. Let's simplify my like terms. I've got 2k squared minus 4k plus 20. Okay. Now I'm going to change colours just to make sure we're working out a bit more. I'm now going to do CB, and that's going to be k minus 8 squared plus k plus 1 minus 6 squared, all of it square rooted, of course. Okay, so I've got k minus 8 squared plus k minus plus 7, because actually it is minus 6 squared. Let's expand this bracket. I've got k squared minus 16k plus 64. And this one here is going to be k squared plus 14k plus 49. Let's put all my like terms together. I've got 2k squared minus 2k plus 113. And again, that's all going to be square rooted, but I'm just not going to write it. And my last one, which is actually the easiest one to work out, which is AB, because I've got all my numbers for AB, so it should all be nice and it should all work out. Difference between these two is going to be 10, so I've got 10 squared plus 11 squared. Okay, and when I actually put these all together, I actually get the square root of 221. Okay, so I've got my three sides for Pythagoras now. So I need to actually just use Pythagoras again, because all of these correspond to lengths. So I know AC, which is 2k squared minus 4k plus 20, plus 2k squared minus 2k plus 113 equals 221. And they've all lost their square root signs because essentially I've squared them. And now I just need to collect all the like terms together and then solve. So I've got 4k squared, okay, minus 4 minus 2 is minus 6k. Now I've got plus 20 plus 113, but then I'm going to be subtracting 221. Okay, so that leaves me with 88 equals to 0. Now that's actually an equation we can solve. I'm going to factorise this. So I'm going to do 4 times 88, negative 88 that is. Okay, oh gosh, not me, which is minus 352. Now I only think of two numbers and multiply to give me 300, minus 352, but add to give me minus 6. And after a little bit of trial and error, it's actually 16 and 22, and it's got to be minus 22. So it's going to be 4k plus 16, 4k minus 22, and again this is fake working out. Let's simplify this. I've got k plus 4, and this one here becomes 2k plus 11, sorry, minus 11. So my values of k is going to be negative 4 and positive 5.5. Okay, and this is a very long way of solving it. Now I just want to talk to you about a different way of solving it, which might be a little bit easier. Now because this is a right angle, I know this is actually going to be perpendicular. So I know the gradient of the line AC times the gradient of the line CB must equal to minus 1. So AC, okay, which is actually going to be, okay, so this is AC. My gradient of that is actually going to be k plus 1 minus 5, which is k minus 4, divided by k plus 2. Okay. Now I know if I times this by CB, okay, which actually gives me the k plus 7 over k minus 8. That's got equal to minus 1. And then all we have to do is solve that. Okay, I'm going to bring both my denominators over. So essentially I'm timesing by k minus 2 and k minus 8. So we've got k minus 4 and k plus 7. It's got equal negative k minus 2, k minus 8. Okay, and then all we need to do is solve all this. Let's expand that. I've got k squared. It's going to be plus 3k minus 28 equals, altogether it's going to be minus k squared plus 6k plus 16. Put all these together, so bring everyone over it bit by bit. We'll do 2k squared minus 3k minus 44 equals 0. And that's actually what we just had previously. It's just half version. So again, I've got my two solutions of k equals minus 4 and k equals 5.5. Oh no.